Right now, everyone wants to be an AI engineer, and I get why. The pay is great. The problems are fun, but as a developer, you want to keep your job safe. So how do you do this in this new age of AI? If you're looking to be an AI engineer, here's a glimpse of what that roadmap might look like. Prompt engineering, LLMs, models, vector databases, fine-tuning might seem overwhelming. The real question is, if you're starting from zero today, what should you learn first and which direction should you take? Should it be Python? Or maybe prompt engineering? Should it be building AI agents or training models? Or asking ChatGPT to create a roadmap for you? It'll just agree with anything you ask it, to be honest. So instead, I'm going to create this video to break it down for you and discuss the basics. Let's begin. First, what is an AI engineer? If you check Google, you'll see that it describes an AI engineer as a software engineer that builds, deploys, and manages applications with the help of an integration of AI models. Now that's very different from a machine learning researcher who might be inventing new AI models and architecture. Or, for example, a data scientist who might be analyzing data, building predictive models, and finding insights. An AI engineer is actually someone who says, cool, this new AI model exists. Let's see how we can turn it into something useful, reliable, secure, and usable for real businesses and people. Now, I want to take a look at the current AI market. Since the release of ChatGPT, companies have been racing to figure out how to use AI properly. And it's not just tech companies. 90% of companies are trying to create AI-related job roles, according to a PwC study. If you actually have a look at the median AI engineer salary, it's somewhere in the six figures range, with even top contenders like Apple and Meta offering somewhere between $200,000 to $500,000 for such roles. So without further ado, let's take a look at this roadmap itself. I'm also going to link it in the description below so you can check it out yourselves in further depth. We've already covered what an AI engineer is, as well as how it's different from an LM engineer or a data scientist. Now, all of these topics will also have additional resources if you want to learn them specifically, which I'll also link below. But this is a roadmap. It's not a course. So just be aware that I'm doing a high level overview of some of the things you'll need to know if you want to be an AI engineer. And the very first step, even before jumping into all of this, I believe, is to learn Python. This is Python, a programming language designed in 1991, and it's essentially the foundation coding language for artificial intelligence as well as machine learning. And this is because it's simple to read and it has a massive ecosystem of well-working APIs. Here's the perfect way to learn it and how I did so myself. I jumped onto Google, searched up Introduction to Python course, and found this really cool one here by DataCamp, which kind of tells you about all the fundamentals, such as how to do different variables, how to create your first functions, use packages, and do all the basics in terms of how to put together methods and packages in a way that you can leverage later on with AI. Now, assuming that you've learned Python, let's have a look at the next important part, which is learning the common terminology when you're in this field. Now, things like AI versus AGI. AGI being artificial general intelligence, kind of where we're trying to head to, where a single AI can do everything. Then we have LLM, which is a large language model. There are a few acronyms here like RAG, which is Retrieval Augmented Generation. It's a way to allow you to pull out information from a vector, which we'll get into a little bit later on. There's a few other things here, prompt engineering, context engineering. Understanding what these mean is pretty important. Obviously, prompt engineering is just creating your prompts properly, whereas context engineering is something that you do before prompting, as setting up kind of the instructions of how you want the AI to operate. There are core LLM elements you should understand how they work, like tokens are essentially how you utilize the AI, and a token can represent essentially a single word or a couple of letters combined. Usually a token in an AI is just how much data you're using from an input or an output. There are a few other things here like temperature, which is how random the AI is when it generates its outputs. And to add on to that, you have top K and top P, as well as repetitive penalties. And these are closely related to how you want the AI to spit out data after you're prompting it. And it's something we'll get into a little bit later on. Let's move on to the next sections, which are how to prompt and do context engineering, because these are quite complex and there's a lot involved here. So let's have a look at some of the terminology and core concepts in this part of the roadmap. But first, I want to be honest about what it takes to develop these skills. AI engineering is currently one of the fastest growing roles in tech. While there are thousands of job listings, looking for genuine hands-on AI experience, simply reading articles or watching tutorials or even learning a roadmap won't cut it. If you want to skill up, research consistently shows that active learning is better than passive learning. Since passive learning only gives retention of up to 20%, active learning, like coding, building projects, or even applying concepts, can push that retention up to 90%. That's exactly why I'm going to recommend DataCamp, today's sponsor for this video. I've personally used DataCamp for the last few years to sharpen my AI abilities as well as my skills in Python. They have this associated AI engineering and developer track, which is specifically designed for developers who want to break into the AI landscape and quickly learn through practical project-based learning. You might have noticed that the structure of this program is actually kind of closely related to today's roadmap. With DataCamp, real Python code can be run directly in your web browser. You can receive instant feedback and build your skills progressively. The track actually includes fundamental AI concepts, from Python basics to working with APIs, vectors, and LLM pipelines. You'll also complete hands-on projects by creating things like chatbots, building summarization tools, or even developing automation scripts that can strengthen your portfolio. Beyond that, it covers job-focused competencies, things like deployment fundamentals, prompt engineering, or integrating AI into real-world applications. There's also a clear pathway to learning industry-recognized AI engineering certification, so you can highlight this on your resume or even your LinkedIn profile. If you're coming in from data science as a background, then DataCamp offers the Associate AI Engineering Data Scientist track tailored for that specific path, including things like PyChart, fine-tuning foundation models like Llama 3 or LM prop practices, or even explainable AI. If you're just getting started, their AI Fundamentals track provides a no-code introduction into core concepts. Honestly, I wish this was around earlier when I began, because I learned a lot of the things originally the hard way. This could have saved me months bouncing between scattered tutorials and ideas and blogs. Instead of piecing things manually together on my own, you can now have a structured path to becoming job ready. So if you're serious about becoming an AI engineer and you want to do so properly, then definitely check out DataCamp, which I've linked in the description below. We'll take a look at context engineering just over here. I think it's better to look at this before jumping into prompt engineering. Context engineering as a whole is essentially giving your AI models a defined idea of exactly what kind of inputs or outputs you want based on a previous number of examples. And in order to do this, you need a few things. The first is external memory. This is kind of like an example of things that it's already done. You can do external memory in a number of different ways, such as pulling it from a database, maybe just having a regular docs, or just pulling in them from different types of methods. And one of those methods is RAG, which is retrieval augmented generation. It's a way of using vectors to store data and then pull them out, because it's kind of using the same sort of ways that the data is working through tokens in a database. Now, another option around this is to do context compaction. So this is where you create the context that you want the AI to utilize, but then that might use up like a lot of tokens, right? And it's going to cost you a lot of money. So you need to compact that context in some way. And there are different ways to do this. I'm not going to get into all of it, but as you can imagine, like context windows are pretty important these days. So essentially being able to reduce those without a loss is becoming its own engineering task, really. There's also context isolation. This isn't even something I've heard of before, but let's have a look at what it says. Context isolation is about keeping different tasks or areas of knowledge separate when working with large language models. So it's essentially like ensuring that one AI agent has one specific bit of context and another one might have different context, or even creating smaller agents hyper-focused on specific tasks. This is becoming more normal as agent swarms are becoming a thing. Now that we've done context engineering, let's have a look at prompt engineering. The first thing to know about is a zero-shot versus few-shot. Now, this is kind of how we showed earlier. Sometimes you want to provide it some context, and zero shot basically means that you aren't providing any context besides the actual prompt itself. Whereas a few shot actually gives a few examples of what you want the AI to do, and this gives it a better indication of whether it's trying to do things like convert a piece of code from JavaScript to TypeScript with a few examples of that, and it's better able to generate accurate results based on those examples. Next up is input format, telling the AI how you're structuring your inputs, and it also helps with your outputs, as well as function calling. Now, this is something that is more often now used. It's become a norm where you allow the AI to call a function within your code. It's kind of what makes MCP possible, and to be able to pull out data that helps with the output of that content. There's prompt caching, which is a technique that stores previous LLM prompts, allowing you to quickly retrieve and reuse them instead of re-prompting everything every single time. Then you have streaming responses. Now, normally the AIs could just give you the response in one big block, but streaming actually allows you to chunk each single word or section of an output in a stream, essentially. And this is cool if you're doing code because you can see the stream of the code coming in. If you're talking to a chatbot, you can see the words coming in one by one, but this wasn't always a thing. It used to just do the whole thing as a block, and personally I think streaming is a lot better, especially for chat-like applications. We then move on to system prompting. Now, system prompting is the prompt that happens before we actually start prompting. It is sometimes what creates the safety guardrails. It tells the AI its personality, how it should interact. It might not even be revealed unless you do some serious prompting, and sometimes it's a little bit more hidden because you might not see it in the history of the chat, but it is something that happens before that chat. Finally, with prompt engineering, there are a few final bits which include things like roles and behaviors, how you want the AI to kind of operate. Do you want it to be helpful or an expert? Do you want it to talk to someone as if they're a 5-year-old? Or maybe even something like your grandparents who might not understand how technology works. You have context, which we kind of already covered, but there's also constraints, which is essentially making sure that the AI doesn't go outside of a certain boundary. And this can involve things like harmful content, or for example, if you're on a travel website with an AI chatbot, you don't want it to do anything other than talk about the airline information. Finally, we have structured outputs. And as prompt engineering, sometimes we have to structure exactly how we want the outputs of the prompts to happen. And this can be in a JSON format, it can be in a text format, it can even be in an XML format. Then we can use that essentially later on in our applications or in our chats. Now that we've got an idea for prompt engineering and context engineering, let's take a look at AI models. There are different types of models to look at. Most models are pre-trained models that we're working with, though sometimes you can retrain them, but for the most part, they come as closed source or open source. Now, the difference is pretty important here, because if you're working with a closed source model, you're probably often working with something like Claude or OpenAI's ChatGPT, and all of these under the hood are closed. We don't have access to those models. And in order to use them, we have to go through their API through the website, but we never actually can download those models and run them on our own machine. And that's the difference with open source models. Open source models are essentially where we have access to the model itself. We can download that model, we can run it up on a Mac Mini, and this is where you run something like Ollama, for example. You might use something like Kimi or Qwen 3.5, and then you can host it or self-host it on your own machine, or that's a Raspberry Pi, a MacBook, or even your own phone these days. With that said, let's take a look at choosing the right model and where you can access them. So if you're accessing closed models like that from Anthropic or from Google or even from OpenAI, then obviously you go on their website. Like Anthropic has Claude, Google has Gemini, OpenAI has ChatGPT. But if you want to access open source models, then normally the place to go is places like Hugging Face, which is essentially a huge library of pre-trained models. And sometimes you get fine-tuned models on there as well. There's a lot you can do on Hugging Face, but there's also other tools like Ollama or LM Studio that allow you to then run those open source models on your own computer. Personally, I prefer LM Studio because it gives you a lot more control as a developer. But if you want something lightweight and really simple to get started with, then usually Ollama is the best choice here. I think for the most part, that covers choosing models, whether they're open source or closed source. So let's actually scroll down and start taking a look at things like embeddings, as well as APIs and SDKs, as these are a huge part of using AI, especially if you're going to be an AI engineer. Now, let's actually continue on with APIs. If you are using a closed source models, then normally they already have APIs that you can access. Like if you go to the website for OpenAI, they have an entire documentation page where you get to learn exactly how to access their models through their API. This is the same for Claude or Gemini, and even if you're running your own model locally through something like Ollama or LM Studio, there are APIs that are predefined that are very similar to their main core products like OpenAI, so that the essential API queries you're running are more or less the same. Let's take a look at what's next, which is embedding models and vector databases. They kind of go hand in hand, which I'll explain why. In terms of embedding models, they're a way of pulling in all of your content, whether it's a single word, a single token, or multiple tokens across multiple words, paragraphs, or even images, and converting them into an embedding, or essentially like a vector. This embedding can be done in different ways. There are embedding models from OpenAI, Gemini, and others, and what they allow you to do is transform that text, image, audio, whatever, into a embedding that can be used later in a database to pull it back out as a reference, kind of like a unique key, but it kind of also does it in a way where it's done in multiple dimensions that can link back to tokens from future searches that you might use. Now, all of this might seem complicated. I've got an entire video dedicated to embeddings, vector databases, how they work and what they are, and I can't simply explain it in a single sentence or two. So definitely check that video out up here if you want to learn more, or even do one of those courses from DataCamp. Once you know how embeddings work, this is where you get to start using vector databases. The vector databases store those embeddings, and then you can use them to search, allowing you to do things like RAG, or even pull out data for context and lots of other stuff. There are a lot of databases that work with vectors as well as with embeddings, and this is where you connect it up to something like Supabase or MongoDB. You can index those, and then you can create searches for similar types of dimensions in those vectors across images or text or audio to find stuff that is relevant to whatever you're searching for. All right, so moving on from this, we're going to get a little bit more depth about RAG. There are things like RAG use cases that we can break down. The difference between RAG and fine-tuning, where, for example, you're using RAG to kind of train your AI to work a certain way, whereas with fine-tuning, you're actually literally training the model so that it can zero-shot what you want it to do. So it's a kind of a different way to approach that. In terms of implementing RAG itself, there's lots of different methodologies such as chunking, embedding, vector databases, the retrieval process, as well as generation. And there are even entire SDKs to doing it properly, which you can jump into and learn more about, like from these over here. But moving on, we're now going to take a closer look at MCP. Firstly, what does MCP stand for? It stands for Model Context Protocol, and it's a set of methodologies to properly allow AIs to essentially do API requests to third parties. It was something created originally by Anthropic, but it's now something that pretty much everyone is doing, and there's articles out there which you can learn more about it. But in terms of how MCP functions, it's essentially a way for you to do a function call or a tool call and use a strict language to pull out data from whatever tool you're requesting. There's usually an MCP host, which is the server itself, and then the MCP client is usually the API or the tool that you're using. So for example, ChatGPT might be the MCP client contacting, for example, Zapier, which might have a number of other connections as the MCP server. We're just really scratching the surface of MCP because I think from a business point of view, if you're working inside of a business like 11 Labs or Midjourney or Canva, you want to work on having AI platforms or AI agents, whatever they are, whether they're on ChatGPT or locally hosted, be able to access your services. It's a way of gaining new customers, and I think a lot of AI engineers will find themselves working with this quite a lot. So understanding how to build an MCP server or a client or connect to them is probably one of the core things you want to do as an AI engineer. But from that, we also have AI safety and ethics, and this is a complex subject because I know that the companies themselves, whether they're Google or Claude, are working on their own version of that. But if you're working inside of a business, then understanding how prompt engineering or security is definitely going to be an important thing. Because, for example, OpenClaw has access to your local machine if you run it on your local machine. That's a big security vulnerability. And prompt injection can be happening in such a number of ways these days. There are honeypots out there for that. People are embedding prompt injection inside of images and all sorts of things. So understanding how prompt injection works, security around AIs and APIs, and what to give your AI access to and where to limit that access is going to be an important thing in the future. Moving on from there, we have other things in terms of AIs, such as using multimodal AIs. There are AI models that have the ability to do text, audio, and imagery, and maybe even video, all in one single model, which is really cool. Understanding how those work and being able to use those efficiently is going to be pretty cool in the future. And I already have some examples here that are available for multimodal AI tasks through OpenAI, DALL-E, NanoBanana that you can check out. Finally, we have AI-assisted coding tools. These are things that are using AI under the hood, and you often hear about them when you hear about things like vibe coding. They include things like Claude Code, Gemini, Codex, Cursor, and I'm using a lot of these myself day to day to build websites, to create programs or automations. And if you want to really jump into that sort of stuff, there's all sorts of resources out there for that.